Hi, this is the third video for week 3 trigonometric functions. This is the third of 7 videos for week 3 and covers the properties of trigonometric functions. These videos are intended to help you to work through the online content for week 3. We recommend that you watch this video with your pen and paper and pause at the relevant times to try the examples for yourself. Properties of trigonometric functions. From 3.2 we have our general sine function in the form our function of x is equal to a, which is our amplitude, and then we have here we apply this sine bx minus c. So this b gives us the period. Omega c is used to find any phase shift, and then d gives us our vertical shift there. So a is our amplitude. So here our amplitude is how high we go here. Then b is our period. Our period here, our regular period of 2 pi. We may have a shorter period here of pi. C is our phase shift. So rather than being here, we may be shifting our phase. And d is our vertical shift. So rather than being here, we may be up here. So the general sine function, f of x, is equal to a sine of b of x minus c plus d, where a is our amplitude. Our period, omega, is 2 pi on the absolute value of b. So remembering for our sine and cosine it's 2 pi, and for our tangent it's simply pi. Our phase shift then becomes c divided by b. So before in the previous examples we only had a single value of b, but here we have c divided by b, and our vertical shift is d. So looking at an example, we want to graph one period of function of x is equal to negative cosine 3x. So the first thing we want to do is to think about here, we have this negative. Here we're meaning, well, it's negative 1 times the cosine of 3x there. So negative 1, that is our amplitude. And so what this means, all we're doing is taking our cosine curve, and we're having here, so here's our regular cosine curve. We start at 1, we're down to negative 1, back up to 1, and so on at 2 pi. So here with our amplitude negative 1, what happens is we flip it. So here instead of being 1, we're going to be negative 1 at 0. Then we're going to go up, 0 will still be 0. Here we'll be at 1. So essentially all we've done is flip this curve here. So we've taken into account this negative 1 amplitude. We still have the 3x here. And we use our period here. Period, we have omega is equal to 2 pi on the absolute value of b. So here that becomes 2 pi on the absolute value of 3. So here this becomes 2 pi on 3. So now our period is 2 pi on 3 rather than 2 pi. So what happens is this all gets squashed right down. So here we're going to end up here. We have here our end of our period here. This will be 2 pi on 3 rather than being the 2 pi. So here at halfway we're at pi on 3. We cut through our x-axis at pi on 6, and then again at pi on 2 there. Okay, so for our next part here, we want to graph at least one period of function of x is equal to tan of x minus 1. So if we think about here, our function of x is a tan bx minus c plus d. All that we're taking into account here is d, which is our vertical shift. So vertical shift of minus 1 means we're going to move it down by 1. So here if we think about our tangent curve, we know 0 we're at 0, and here pi on 2 we have an asymptote. Here at pi is where we're cutting through our x-axis again, And here at 3 pi on 2, we have another asymptote. Then here, again at 2 pi, we cut through our x-axis, and so on. So we're going here, we go through here, another asymptote at negative pi on 2, and so on. So we only really need to look at one of these. So it's tan of x, and we're minus 1. So what we're saying here, instead of being at 0 where we cut through, that's going to be at negative 1 here. So here, so here, instead of being at the 0 at pi, we're going to be at negative 1. And our curve still follows the same shape, going towards these asymptotes and continuing on to infinity in each of those. So again, here, we're going to be there and follow through. Negative 1 and follow through there. So our completed graph, it looks exactly the same as our tangent curve, just moved down by this one here. For our next example, we want to graph at least one period of function of x is equal to sine of pi x plus pi on 2 plus 2. So now we're jumping into something that's a lot more complicated. If we write out our rule up here, our function of x is a sine of b x minus c plus d. So here our a is equal to 1. B is equal to pi. C is equal to pi on 2. And here D is equal to 2. So here our amplitude is 1. For B, we've got here our pi. We're going to work out omega is then 2 pi on the absolute value of B. So 2 pi on pi. Our pi's cancel out, and so here our period will be equal to 2. For C, we have pi on 2, so that it comes, we lead it through to our phase shift is equal to C on B. And we have pi on 2 divided by pi. So here, if we think about it this way, pi on 2 divided by pi, or pi on 2 times 1 on pi, here they cancel out and we get a half. So our phase shift is equal to a half. And then D is our vertical shift. So we have a vertical shift equal to 2. So here, if we think this through, our amplitude is 1, so that's easy enough here. We know we have a vertical shift of 2, so rather than starting at 0 and our curve going here at 0, we're going to be up here at 2. Our amplitude is still equal to 1, so here we're going up and down to 1 and to 3. So we can draw our general sine shape in here and back to there. So we know we go up to 3, down to 1. So now we know here, this is equal to 2. And okay, so now that we're done with our period, our vertical shift and our amplitude, now we can take our phase shift into account. We have a phase shift of a half. We notice that it's positive, so we're moving our whole curve to the left by a half. So here, we're going to be finishing up here at 1.5. So this is where our 1 is here. So we're finishing up here at 1.5. And it's just following exactly the same curve shape and back here. So we're going to be going from negative a half through to 1.5 in that one period there. So here we start with our usual graph. We shift our sine wave 2 up because of our D, our vertical shift. Our regular period, instead of being 2 pi, changes to 2. So we can just, if we're doing this, we can just renumber our x-axis, and then we shift to the left by a half, so we can shift it all over there. So we're going from here, -1/2 to 1 1/2.